Hello everyone, and welcome back to another how-to video by Miss Sackridge. Today we are going to be examining how to find the measure of a missing angle when given different characteristics or similarities. To find the missing angle measure, it is important to understand the different angle types such as complementary, supplementary, and adjacent angles. And once we know more about different types of angles, we can see how the vertex of an angle can help us to determine the value of a missing angle. And lastly, sums between angles can help us to determine the sum or equivalence between angles such as interior, exterior, vertical, and corresponding angles. And through this video, you will be asked to answer some questions and check for a review along the way. So if you ever need more time to solve a problem, just pause the video and show your work. So right now, it might be a good idea to pause this video and go get a piece of paper and something to write with. We'll be looking at the different angle types. So before we get into the definition of the angle types, we first need to define the word vertex, because this is a word you're going to be hearing a lot. And this word we've used in the past, and it is where two lines or rays of an angle come together at a point. So right here, where these two rays come together, that's a vertex. Examples here. Complementary are two angles where their sum is 90 degrees. So 38 degrees and 52 degrees, if we were to add those together, that would be equivalent to 90 degrees. Supplementary angles are two angles where their sum is 180 degrees. So if we look at this a little closer, 112 degrees plus 68 degrees is equivalent to 180 degrees. And adjacent angles are two angles that have a common vertex and a common side. So if we're looking at this example here, angle 1 and angle 2 have the same vertex, their rays meet at the same point, and they share this side in common. But adjacent angles don't have to have a specific sum, where complementary and supplementary do. Next, we're going to be looking at which angles are complementary. So take some time, maybe pause this video, and on that sheet of paper that you got, start listing them all out. Okay, if you said angle ABC, this angle right here, and DEF, this angle, were complementary, you are correct. However, there is also two more sets of complementary angles, and that is IGH and MON. Those have a sum of 90 degrees, as well as JKL and PQR. So, okay, next you're going to be figuring out which angles are supplementary. So, once again, you need to pause this video to take a minute to do that and figure out which ones are correct. Please do so. So if you said problems 3 and 4, you are correct. 3 and 4 both have the sum of 180 degrees. And if you look, next we are naming a pair of adjacent angles. So if you need to pause this video and go back and remind yourself what an adjacent angle is, please do so. And take some time to answer this question. Write down as many pairs of adjacent angles as you can find. So you probably noticed there's a lot of adjacent angles here. So is angles A and B. They share a common vertex right here, and they also have a same side that splits the angles. So as long as you found adjacent angles that share a common vertex and also share a common side, then you are correct. Looking a little bit more at angles that share a vertex. So starting with this example here, when looking at this picture, we can see that line AB right here is a straight line. And as we have learned in previous lessons, we know that a straight line is 180 degrees. So that means that the sum of the two angle measures that are given here need to add up to 180 degrees. So just take a minute to see if you can figure out the value of s on your own, and pause the video if you would like some more time to think and figure it out. 3s and s need to equal 180 degrees. We can create the equation 3s plus s equals 180. And once you have this set up, all you need to do is solve this simple algebraic equation, which is similar to when we've solved algebraic equations in the past. So 3s plus s is equivalent to 4s, and we just set 4s equal to 180. And then to solve and isolate x, we just need to 2 to both sides by 4. So we are left with s equals 45. And you can test. Okay, and next we're going to be talking about angle similarities with interior and exterior, vertical and corresponding. And these are going to be some new vocab words for you guys. So, an example of interior, and they're fairly similar to each other. There are some key differences that set them apart. So, for example, interior angles are highlighted here in this picture to show that they are found inside parallel lines. So here is the set of parallel lines that I'm looking at. They're going horizontal. And this right here is our transversal that I was talking about, parallel lines. Interesting characteristic of interior angles is that their sum is equivalent to 180 degrees. And we will discuss this later in the video, how we can know the sum of different angle sets. So once again, in this picture, 4 and 10 are interior angles, as well as 8 and 14. They fall inside parallel lines and are located on the same side of the transversal. So can you find any other sets of interior angles throughout? Next is alternate interior angles. And although they're very similar to interior angles, they fall on opposite sides of the transversal. They are still within the parallel lines, and fall on the transversal that crosses through those parallel lines. So alternate interior angles are always equal in angle measure, and the set of alternate interior angles in this example are 3 and 10, as well as 7 and 14. And this, you find any other sets of alternate interior angles, and remember to write. Looking at exterior angles. Exterior angles are just the opposite of interior angles. They fall outside of the parallel lines. There are similarities between exterior and interior angles, and one similarity is that they both fall on the same side of the transversal. So right here is our transversal, and both angles that are highlighted, 1 and 11, fall on that same side. Similarity is that they both 1 and 11 add up to 180 degrees again, just like our interior angle sets. And 1 and 11 are exterior angles, as well as 5 and 15. This example, let me know if you can see any more. Talking about alternate exterior angles. And once again, alternate exterior angles are also very similar to alternate interior angles. The angles still fall on opposite sides of the transversal and are equal to an angle measure. So angle 2 is equivalent to angle 11. They're both located on the outside of the parallel lines, and they're on opposite sides of the transversal. So if you can find any other sets of alternate exterior angles. Corresponding angles are 2 angles that fall either above or below parallel lines, such as angles 1 and 9 or angles 7 and 15. They also have to fall on the same side of the transversal. And both of these angles, like angle 1 and angle 9, those are equal in angle measure. You can find any more sets of corresponding angles. Next example we're going to look at is vertical angles. And vertical angles share a vertex and they are equivalent. So vertical angles can be found where the transversal cuts through one of the parallel lines. Vertical angles are always across from each other as well. So angles 2 and 3 here are vertical. There's a parallel line here and the transversal cuts through it. and opposite sides of that cut make vertical angles. So there's not a common side shared here between these two, just a common vertex. So come down if you find other vertical angles. How to solve problems like this coming up, but let me know if you can think of ways that we can begin to solve this. And ideas with you to class, and have a great day, everyone.